anything that I get through today is just stuff that we have to talk about tomorrow, right? So, this is just our basic introduction. I did print the notes because it's kind of wordy, so you might just want to grab a highlighter and kind of highlight some of these. We will write in a few things. Statistics in general, again, I'm not going to like give you a test and ask you to write this definition. But when I talk about statistics, that's the science of collecting, organizing, summarizing, and analyzing information to draw conclusions. You know, we're going to start out, we're going to have to find some data, figure out how we're going to gather that data, how can we put it together so that we can analyze it and figure out what it's telling us. So the data that I'm referring to, it just describes some characteristics. So it's whatever I'm interested in. Maybe I want to look at the height of people that drink Monroe City water versus people that drink water elsewhere. Well, I don't know. So that would be my data. That's the thing that I would be collecting, their heights. Hour slept last night, political party. The thing about data is the values are going to vary. You know, if I ask each one of you, what's your height? Are you all going to give me the same answer?
It depends.
Well, that is very true. Thank you for pointing that out. But there's some variability in the data. It's not all going to look the same. And you may have some values that are way different than others. You know, if I brought my kindergartner in here and asked him the height along with you guys, his value is going to be a lot different than yours. So data values are going to vary. Our goal is to be able to look at that variability and understand it, figure out what it is telling us. Something that I want to talk about with the data, it's not always going to be accurate. It depends on how it was collected in the first place. So let's say I wanted to figure out how many people in the high school are obese. And I gave everybody a survey and asked them to write their weight down. Would I get accurate information back? Probably not, because some people are probably going to fudge their weight a little bit, right? So you have to understand that just because you have a set of data doesn't necessarily mean it's accurate. It also doesn't mean that it reflects the entire population. If I found the average weight in this classroom and then said, okay, average weight in this classroom is 130 pounds. That must be the average weight of the entire high school. Is that going to be accurate?
It might be similar.
It might be similar, but it might not, right? So we have to understand, we need to look at the bigger picture here. If you were just looking at an article in a magazine, they love to spout statistics. And they may say, I don't know, let's say 95% of voters are in favor of President Trump's new policy. They have a number. They can't even tell you where they got that number.
But they, like, whenever they do, like, the phone interviews, like, they literally, like, if you get a call, like, survey or whatever, like, they literally ask you questions, and they'll be like, well, we're not interested.
Exactly.
So they can...
Their data is skewed. So you have to be able to look at something and understand if it's accurate. Just because you see a table in a newspaper, does it mean that their information is accurate? Does it mean that they went about collecting it the right way? We're going to talk about good ways of collecting data and bad ways so that you are more knowledgeable when you go out, that you don't just believe every statistic that you might see. You know, if like we wanted to figure out the average income in Monroe City, and each of you went out and picked 100 households in Missouri, or in Monroe City, and found their average income, and then came back to me. So each of you picked a different 100 households. Would all of you have the same number? No. Would all of your data be accurate? You know, did you find the 100 households and find their average? Yeah. But depending on that sample that we choose, that group that we pick from, we're going to get different answers. So we have to talk about statistics in terms of, you know, how much variability does it have? We'll talk about how much error is in it, so we can get a window of possible values. Because unless we asked every single household, we wouldn't get the true number. these terms, population and sample, are huge. I am going to talk about these all the time. So probably two of the most important terms in this section. The population is the entire group being studied. If I wanted the average household income in Monroe City, then my population is every household in Monroe City. The sample is a smaller group of that, because is it feasible to think we're going to go out and talk to every single household? Probably not. So we may only talk to 100 of them. So that 100 would be our sample. It's a group we chose out of a larger group. Okay, it would be like if I wanted to poll you guys in this class, and I just picked one person from each table to answer my question. You guys, the class, is my population. The one person from each table is the sample. It's a group from the population. An individual is just one person. Skyly is an individual in my population. She is one person. Do you guys understand the difference there? So, two main types of statistics, descriptive and inferential. There are two types. Descriptive, you are actually describing something. You know, it involves taking and summarizing our data. We're not making any guesses about what it means. We're going to say, I polled 100 people and this is the answer I got. Okay, I'm just telling you what I found. Inferential is when you try to make guesses about what that means. You know, everybody in this classroom likes President Trump, so I'm going to assume that everybody in this entire high school likes President Trump. There's a little bit of error in the inferential, right? If you're trying to take a group and assume that their response fits everybody, is that going to be accurate? Not always. Could it be? Sure. But it's not always. So descriptive, you're just telling me exactly what you have. Inferential is when you're taking that information and trying to draw some kind of conclusion from it. All right. These next two terms are also really important, statistic and parameter. So if a statistic, I think the S's go together. A statistic is based on a sample. So statistic goes with the sample. And then the P's go together. A parameter is talking about the population. What's the difference between a sample and a population?
Sample is part of it.
Right, sample is part of it, population is everybody. So, if I said the average class size of the math department is 18 students. And then I said based upon that, well, is that descriptive or inferential? If I took all the math classes and found the average class size, that's descriptive. If I said, so the high school average class size is 18 students, that's inferential, because I'm taking the information I found and extending it to everybody. Right. So that 18 students, that applies to my sample, right? My math classes. So that is a statistic. If I said the average math or the average class size is 18 students, that came from my sample. So that's a statistic. Now if I really went and did the whole high school and I came back that average class size was 16 students, that was for every class in the high school. So that would be a parameter because it fits everybody. That came from the population.
16 would be the?
Yeah, if every class in the high school and I found the average class size and got 16, that every class was my population, so the 16 would be my parameter. Two more minutes? Let's do the first example and then we'll stop. Okay, so we're going to decide if each of these is descriptive or inferential. The average age of 500 students surveyed in your institution is 23 years.
Wasn't there only 500 students surveyed?
Yeah, it's just saying out of those 500, the average age of those students was 23. That's descriptive. Based on a sample of 10,000 Americans, it is fair to say that 70% of all Americans are overweight. Inferential. 80% of students in your statistics class dislike true-false questions. It's true. That's just talking about my class. Based on a sample of 20,000 college students, we may conclude that 80% of all college students dislike true-false questions. Inferential. Because we only surveyed the sample, but we are making an assumption about everybody. Any questions for me so far? Wasn't too painful.